Hello and welcome back. Today we'll be doing question 7 from the 2021 MAT. So let's get started. Throughout this question, all functions will be Boolean functions of Boolean input variables. A Boolean variable can be 0 or 1. A Boolean function may have one or more Boolean input variables, and the output of a Boolean function is also either 0 or 1. Three elementary Boolean functions are defined as follows. The function min of x1 to xk can take any number of inputs. It outputs the value 1 exactly when each of its inputs is 1. That is, the output of the function is the minimum value among its inputs. The function max of x1 to xk can take any number of inputs. It outputs the value 1 exactly when at least one of its inputs is 1. That is, the output of the function is the maximum value among its inputs. The function flip takes a single input and is defined as flip of x1 is equal to 1 minus x1. First, we will consider Boolean functions obtained by combining the three elementary Boolean functions. One such function is shown below. Part 1. Describe in words when the function f outputs 1 and when it outputs 0. Part 2. The function majority of x1 to xk takes k inputs and outputs 1 exactly when strictly greater than k by 2 of its inputs are 1. Explain how you could combine elementary Boolean functions to obtain the following functions. A. Majority of x1, x2, and B. Majority of x1, x2, x3. Now we will consider Boolean functions that can be obtained by combining only majority functions. Part 3. There are exactly 16 distinct Boolean functions of two input variables. Some of these can be represented using only majority functions that take 3 inputs. The use of 0 or 1 as fixed inputs to majority is permitted. For example, majority x1, x2, 1 represents the function max of x1, x2. Find any 4 other Boolean functions of 2 variables that can be represented by combining 1 or more majority functions of 3 inputs. Write your answer in terms of majority functions. Part 4. Give an example of a Boolean function g of 2 input variables that cannot be represented by combining majority functions of any number of inputs. You should write your answer by explicitly specifying g of 0, 0, g of 0, 1, g of 1, 0, and g of 1, 1. Justify your answer. Pause the video to have a think, and once you're ready, we'll restart to see if you were correct. Let's get started. So firstly, before completing the question, I'd notice that min of a, b, c is simply a and b and c in logic. Similarly, max of a, b, c is equal to a or b or c, and flip a is simply equal to not a. Here I've used the mathematical logic symbols, however you may or may not be more familiar with the programming ones. Now let's get started with our question. So, firstly, we have part 1. F of x1, x2, x3 is equal to x1 or x2 or x3 ANDed with not of x1 and x2 and x3, which is equal to 1. Therefore, x1 or x2 or x3 is equal to 1, and x1 and x2 and x3 is equal to 0. So at least one of the inputs needs to be 1 for the left-hand side to be true, and at least one of the inputs is 0 needs to be true for the right-hand side to be true. And therefore, if all of the inputs are the same, f produces 0, and if they are different, then f produces 1. Now we can move on to part 2. For a, both inputs will need to be 1, so we can just use x1 and x2. That is min of x1 and x2. For part B, at most one input may be 0, so we have x1 and x2, or x1 and x3, or x2 and x3, which is max of min x1, x2, min x1, x3, and min x2, x3. For part 3, we can actually do some cheating and we can just say majority AB0, majority AAB, majority ABB, and majority 111. Here I've given the truth tables for all of these below. Now we can move on to part 4. G of x1, x2 is equal to x1 XOR x2 cannot be formed, as increasing any input of the majority function cannot decrease its output. A property XOR does not obey, as 1 XOR 0 is 1, but 1 XOR 1 is 0. I've given the truth table for the XOR to the left here. Now let's move on to the last part of the question. In the last part, you may express Boolean functions by combining any of the elementary Boolean functions or the majority function. Part 5. Consider 4 input variables x1, x2, x3, x4. Let z1 equal min x1, x2, z2 equals min x2, x3, z3 equal min x3, x4, and z4 equal min x4, x1. It is sometimes possible to represent a function s of x1, x2, x3, x4 using a function t of z1, z2, z3, z4. For example, min of x1, x2, x3, x4 is equal to min z1, z2, z3, z4, as both functions output 1 if and only if all 4 xi are 1. Can you represent the following functions of inputs x1, x2, x3, x4 as some Boolean function of inputs z1, z2, z3, and z4? Justify your answers. Part A. Majority of x1, x2, x3, x4. B. The function parity x1, x2, x3, x4, which outputs 1 exactly when an odd number of its inputs are 1. Let's work on part A first. So, for the left-hand side to be 1, then we need at least 3 of xk to be 1, which means that at least 2 of zk will be 1. Therefore, we can try and work from majority of z1, z2, z3, z4, and to balance the function such that 2 1 inputs will give a majority, we can just stick another 1 input into the end, giving us majority z1, z2, z3, z4, 1. Part B. Now, the function t will give an incorrect output in at least one case if we can confuse it into seeing 2 different x1, x2, x3, x4 as the same z1, z2, z3, z4. For example, having x1 as 1 or 0 and all the other x's as 0 will give all z's equal 0. So t of z1, z2, z3, and z4 will be wrong in at least one of the 2 cases above. And that's my answer. If you liked our video, please like and subscribe, and we'll see you next time for some more fun maths problems. Thanks for watching, and goodbye.